we have a little time for questions. I already put some together. Okay, so the first question that I have here is to João Soares. It's from Katia Silva, and she's asking, what are the parameters that we need to consider in order to choose the best optimization approach? And if there is a way, if there are any approach different than meteoristic or deterministic optimization?
Hello again. Thank you for the question. To choose the best optimization approach, you first need to think, like I discussed, like I presented in the presentation, you need to think which problem are you solving. And like Fernando told, if you are solving a problem that is relatively small and has been tackled with classical optimization approach, and this approach, these tools still work well, you don't need to use meteoristics. You don't need to use tools from evolutionary computation department. And the parameters, the size of the problem is one of the parameters. If you have uncertainty in your parameters in your problem, then you might already is a warning. So if you have uncertainty, perhaps your classical approach won't work so well. But usually you have to think, if you have a large scale problem, if the size of your problem will grow, maybe if you are implementing your problem and the size in instances is yet small, but it can grow in the future. So maybe classical optimization, traditional tools will work for a while, but as your problem scales, it won't work anymore. And if you have uncertainty in your problem, if you are not sure of what parameters are you dealing with, it means that some way or another, the classical optimization will eventually fail, because even if computer resources are being better over time, as they are better now than 20 years ago, but still the problems are also increasing in the complexity. You also want more accurate solutions, and so you also need to accompany. So you also need to get going with this. You need to have tools like from evolutionary computation that can solve these problems with more accuracy. I don't know if Katia, it's from Katia, right? If she can speak to, I don't know if I answered her question, but she can, you can raise her voice if she wants to make an intervention.
Yeah, that was not the idea, but it's okay.
It's okay.
I don't know if she will accept it.
Well, yeah. If she, maybe I was trying to understand their question. I'm not sure. And of course, you can always, let me just finish. You can always merge concepts of classical optimization with meteoristics, and they are called hybrid optimization. So we see more and more often approaches that use as local search, use classical optimization. So in this local search, small instance of the problem, they use very well known methods that work well for that small instance. And then in a more global search, in a more exploration search, they use the core of meteoristics. So it is all, we also see some ensembles of meteoristics with classical optimization, and they are usually called hybrid optimization frameworks. But Katia, sorry, if you can. Not sure if this was your question, but.
Yeah.
She said yes. She said
yes. And the mic don't work, so let's pass to the next one. It's for Fernando Lezama, and the question is from Brigitte Teixeira. Which are the best programming languages that are being used to apply evolutionary algorithms, and which of them has better performance since the computational resources are a crucial factor?
Yeah, thank you. I hope now you can listen me
Yes.
to me better.
Now
Okay,
it's perfect.
excellent. Sorry for before, but yeah, regarding the question, well, yeah, you're right. The computational performance is critical in these kind of applications, but also I believe that there is no definitive answer to this question. What I can tell you is about my experience. For example, these days, Python and R languages are very popular because they are open source languages. So you can apply your algorithms and put it to run in almost any machine that can run this without the need of paying a license. In our group, we use Matlab. Matlab has some limitations in which regards to the performance of cycles or iterations. But when it comes to, for example, matrix operations, MATLAB is very powerful, and there are a lot of researchers that use it. So it can be also an option when you are applying these tools. Also, it's a very easy language to understand and to use. And finally, there are some languages that are used for commercial purposes, like Java and C++, for example, that are the more popular ones. So I think that it depends on the application that you want to use. My recommendation is that since these days everybody is using Python and R, and if you are starting with this kind of techniques, or even if you want to continue using it, is to switch to these languages, because most of the resources will be fine there. But the algorithms are something that it's out of the software that you are using it, so you can apply to any of the you can use any of the softwares available. I think that's my reply. Thank you.
Okay, thanks. And now a question for Pedro Faria from Gabriel Santos, and I will merge with also a question with Katia Silva. That is, in your opinion, what are the main difficulties for implementing the smart grids in Portugal to release all its benefits? And how do you see that an aggregator and the grid can bring the end user to play an active role in the smart grid?
Yes, this in some way, Professor Zita this afternoon talk about kind of this question for demand response, and demand response and smart grid are not the same thing, but they should go together. In fact, smart grid is a big buzzword, so everything and anything can be a smart grid related topic, but in fact, I think that the great confusion still be that the smart grid and smart metering or home automation is confused with the real smart grid, let's say. So real intelligence, real support to the grid intelligence and consumer intelligent decisions. I think that even GDPR came to make the world more difficult, but I think it's something that we should handle, because even in demand response and smart metering was something that we say, okay, we can see that in the future the grid operator will know everything about me, and even in demand response the aggregator or the grid operator will know a lot about me, that other people can use that information. But I think in this sense GDPR will give us a step, so all ethics are formalized and protected, will be protected now by that way. So that issue about demand response and smart grid will proceed like that. And of course, as Professor Zita mentioned, some directives are coming from European Union enforcing this, and we will need the time, but to move it to our national regulations. But of course, each country is free to do it in a more deep or more soft way. Yeah, it depends on all of us that we are on academia, collaborating with innovation and the regulation authorities, and enforce this. So it depends on all of us.
Okay, thank you.
Thank you.
Now I have here a question for all of you that is not directed to all of you, but I believe that all your experience can answer this, and we will have three different opinions. The question is from Gabriel Santos, and is asking, from your experience, what type of algorithms, deterministic versus stochastic, usually have best results regarding efficiency and effectiveness? Sorry for that.
Okay, so who will start to reply this?
You can
Well,
start.
yeah, okay. I can start with this. Yeah, well, the difference between deterministic and stochastic is that deterministic can guarantee you, can provide you theoretical guarantees of finding the optimal. So I believe that if you are able to implement a deterministic approach, it will be more efficient, and it will be better for almost any problem. When you don't have that possibility, or when you apply these deterministic approaches and they fail because, for example, large scale optimization problems or uncertainty or other factors, then you can switch to a stochastic, because in those cases, the stochastic might be better than deterministic. But in my opinion, you should go first with deterministic, and only if you are not able to apply this kind of technique, then you should shift to a stochastic. That's my contribution to this question. Thank you.
I think I already answered this in the previous question from Katya. I think it's linked. It all depends, the efficiency to solve a problem and to get the results and the effectiveness of this result depends also on the type of the problem. So if you have a large scale problem with a lot of uncertainty, obviously the deterministic is not, you want to be effective and want to be efficient, you see. So a stochastic method, like some evolutionary algorithm, will be better in that problem. So this depends, again, what problem are you solving? This should be the question. If the problem is really simple, if your problem won't scale, if your problem will stay the same for the next 10 years like that in your application, then you will be good with the deterministic approach, most likely. Otherwise, you need to have either two methods online, or hybrid methods, or a stochastic method. And I think this is my opinion.
Okay. Pedro, do you want to add something?
Not really. I guess I see, anyway, I can say the interest on this technique is the way that they are of light. You can have, of course, very complex optimization models. I mean, not the formulation, but the technique, that can be also heavy, but also you can make very light ones that you can run in very light processing targets. So that is another point, that is not the complexity of your problem, but how do you want to solve it locally, remotely? Do you have cloud available, IoT, and so on? So these are other questions to the equation.
And remember that in this field of computational intelligence, there is one fundamental theorem that is widely accepted, that is, as I explained, the no free lunch theorem. And it means that methods developed by researchers in the computational intelligence department, they are every day they are more and more, and we cannot say that this method is better to solve a problem than the other before. Maybe in a class of problems or one type of problem, it demonstrates to be better today, okay? And we can prove, we can say that the results are statistically significant, but we cannot say that tomorrow this will be like that. So we cannot have a guarantee of convergence. We cannot prove that this method will be better for the eternity, you see? So this free lunch theorem is very important to keep in mind when we join the computational intelligence field. So that's why there are many methods emerging every year, because there are also new problems emerging. And for these new problems, usually you develop new methods or new application-specific methods that will auto-perform or be better than the previous ones developed. And sometimes even better than some classical optimization tools. So it depends. It's very tied to the problem you are solving. So it's very challenging.
Okay, thank you all. And now just a last question that arrived from Sarah. Sorry for the pronunciation of the name, but is for Fernando Lezama. Have you used or tried any reduced order techniques in your algorithms?
Yes. Well, actually, personally, I haven't used any of these techniques because I haven't had the need. Most of the fitness functions that we have implemented here in GCAD are fitness functions that can be solved very fast. Even with large-scale optimization problems that we have been modeling, they are usually linear models, so we don't need to use this kind of reduced order techniques. But it is true that we want to jump now to more complex problems in which perhaps we are going to require the use of meta models. There are one line of research that is related with surrogate models that try to modify the original model and to make an approximation of this model to be more efficient when you simulate these very heavy, expensive functions. And in these cases, perhaps we are going to need the use of this kind of reduced order techniques. But so far, we haven't had this issue, so that's why we haven't used it. But we keep in mind that it can be implemented and incorporated also within the framework of the evolutionary algorithms. Thank you.
So thank you all for speaking, and thank you all for the assistance. And we can finish now part 2 and the course.